go to page 31 in your journal and copy down the vocabulary terms. Then look at the core concepts for f of x equals ax squared plus bx plus c. This is our general or standard form. When a is greater than 0, notice that our u goes up. When a is less than 0, notice that it's an upside down u. So when there's a negative in front, it's going to be upside down or reflected over the x-axis. Read each of these points below to learn more about this function. Now go to example 1 in your notes for section 2.2, and we are going to label the vertex and the axis of symmetry. I know my vertex is HK, and from this problem, I can see that H is going to be -3 and K is 4. Remember, we do the opposite of what's inside the parentheses. So go ahead and plot -3, 4. There's my vertex, and my axis of symmetry is going to be just the x value. So I'm going to label it AOS is going to be x equals -3. And draw a dotted line along the vertical line -3. To finish this graph, I'm going to look at my vertex, -3, 4, and I'm going to pick one point to the left, which would be -4 for the x, and one point to the right, which would be -2, and I'm going to try to solve for those points. If I plug -2 in for my x value, I'm going to get 2. And if I plug in -4, I'll also get 2. So if I plot these on my graph, now I can connect my curve, and I've just graphed f of x. Go to the next page in your notes and look at example 2. This is in the standard form that we were just talking about, ax squared plus bx plus c. I know that my axis of symmetry is going to be at -b over 2a, so I'll calculate that. My b is -6, so I'll have -6 over 2 times my a, which is 3, and that will simplify to just be 1. So my axis of symmetry is at x equals 1, and my vertex, I plug in 1 and get the y value. When I plugged this in, I got -2, and then I plotted my point on my graph. Now to get the y-intercept, it's just 0, c. That is going to be my y-intercept. So 0, 1 will be my y-intercept, and I can plot that point as well. And then reflect it over your axis of symmetry, which would be the point 2, 1, and there's my reflected point. These are the points that you can use to connect your graph. You could also get a table and fill in the points on the table. These would be the points on the table, and then when you graph it, you have your f of x function graphed. Looking back at page 32 of your journal, we see minimum and maximum values. When our function is in a U shape, it has a minimum at the vertex. When our function is an upside down U, it has a maximum at the vertex. To calculate those, they tell you below, and they also talk about domain and range. Read about increasing and decreasing as well, and then go to example 3 in your notes. If we read example 3, we want to find minimum or maximum value of f of x, and it's in ax squared plus bx plus c form. Then we want to describe the domain and range and where the function's increasing and decreasing. First, to get the minimum or maximum, we need to get the vertex. So we want to calculate -b over 2a. That will be 2. When I calculate that, I also want to find f of 2, which is my y value. So I substitute 2 in for x in this function. And I should get -3. You can check my math to make sure that's right. This tells us that there is a minimum and the minimum is -3 at the point x equals 2. Then we want to talk about domain and range. Domain for all of our functions is all real numbers. And the range, if I was to graph this, a is positive, so I know it's going to be a u going up. So my range is y is greater than or equal to -3. Then we have to talk about where this function is increasing and where the function is decreasing. We talk about this in terms of x. So if I was to graph this function, it would look like this u right here, right? We would have a u. My function is decreasing as I go from left to right. It starts out decreasing. Then I get to the vertex and it switches and it starts increasing after the vertex. So that means my function is increasing when x is greater than 2 and decreasing when x is less than 2.